Hey guys, welcome back to my channel Success Engineering Official. So now we are going to start the table split system for ground floor. As you can see here, we have created until this planning and translator as well as toilet. So we are going to continue the remaining spaces is our here corridor, then telecom room, electrical room, and pantry, storage, gents, toilets. So for from one system we have to give in all the spaces. So let us start now. Let me create one more system here, which is ground floor corridor plus ground floor corridor. Okay. So okay, we have to create two system. One is for the corridor and one is for these spaces. So let us start now. Let me create here system for corridor. Let me duplicate this. Okay, then let me check the last which one is the last spaces. Here is the 9 split unit 9. So let us duplicate this split unit 9. Okay, and just rename this. Here you can see this is the air system properties. So there are three tabs here. First one is general tabs. Second one is OOS outdoor air system component. So this will be applicable for the package unit. That's why this is hidden. And third one is zone component. So in the zone component we have to add the spaces into the zone, and fourth one is sizing data. So we will see. Let us see one by one. So go to the general tab, and first one is in the general tab air system name. So let us duplicate this air system name. Make it corridor. Okay, so this is caps lock corridor ground floor split unit 10. Okay, and next is equipment type. So in the equipment type you have to select the terminal unit. So because terminal unit is comes under a split unit. Okay, so in this list you can see here the package unit rooftop, package unit vertical, split air handling unit. So this split air handling unit is AHU. So do not check this. Chilled water air handling unit, and this is the split DX. Okay, DS and DX AHU. So we are dealing about a split unit. So check this terminal unit. Okay, and the air system type is a split DX fine coil. A split unit is comes under a split DX fine coil. Okay, so let us select this. Number of zone is 1 because one space one zone. Okay, and then go to the zone component. So in the zone component you can see here the first one is spaces. So here you can see there are three spaces added in the one system. So let us select this. Click on remove and add the corridor ground floor. So okay, look for the corridor ground floor. Look in the list. So this is the corridor ground floor. Okay, and here you can change the zone name, which is corridor. Okay, so this corridor ground floor spaces is added in the corridor zone. So let us rename this and then go to the thermostats. So in the thermostats you do not change anything here because this setting is already done in the one system. So you should keep this between 21 to 23, 21 plus minus 2. Okay, the cooling thermostat set point, and unoccupied is 26. Okay, and this is heating thermostats leave as it is because we are not dealing about heating system. Okay, so leave as it is, and this throttling as thermostat thermostat throttling range is difference between cooling and heating. So do not change this one. And here you can select thermostat schedule. Then go to the common data. So in the common data there is a cooling coil and heating coil. So we are dealing about cooling coil. So just uncheck this heating coil. Okay, and then in the cooling coil there is supply data and design supply temperature. So design supply temperature is 12 degree and coil bypass factor is 0.12, and cooling source is air cooled DX. Okay, so this is the air system DX type. So no need to change anything, and schedule is from January to December, so each and everything will be switch on. Okay, do not make off, it should be on. Okay, everything should be on. Okay, then go to the terminal unit. So in the terminal unit you can see here all zone are the same. So in this already selected here, zone is all zone, and fan coil unit, this is the fan coil unit, and air distribution. So air distribution nothing. Here is the total static. So total static is nothing but this. Here you can see the BHP total static motor kilowatt whatever. Here is given so many parameters. So first you have to select the total statics. So based on the total static, the system will assume the heat dissipation from the motor. Okay, so keep it. This is the small system, so keep it. Just assume 50 or 100 Pascal. Okay. Then go to the zone sizing. In the zone sizing, you can see here there are two: this zone sizing data and zone system sizing and zone sizing. Okay. So in the system sizing, you have to, if you uncheck this, it is not going. This is automatic selected by the system. Okay, checked by the software. So in the system sizing, you can see here the safety factor is given. Okay, so in the safety factor, you should keep here cooling sensible 10% and latent is 10% as well. And if you are dealing about heating system, you should keep here heating as well 10%. Okay, and chill water system, if you deal about hydronic sizing specification chill water system, so you should keep here chill water in and out delta T temperature difference between in and out. Okay. Then go to the zone sizing. So in the zone sizing, you can see here the zone airflow sizing method is sum of space airflow rate. Okay, and here is the space airflow sizing is individual peak space load. Okay, and your zone is corridor. Okay, and here is the computer generated. The sizing data is computer generated. Do not make user defined. Okay, we need computer generated, so no need if you want to change you can select the user defined. I want to generate by computer, so let us select this and click OK. So this the system for the corridor is created. So let us check the input data first. So what I am going to do for the input data, just select this corridor, and here you can see this is the quick access toolbar. Okay, this is called quick access toolbar. So in this you can see here this icon looks like taper. Okay, taper offset duct. So in this you can just right click. Okay, just click here to view the input report. Okay, so just click this and software will generate the input report. So here you can see the corridor ground floor split unit 10 input data, and in the first one there is general details which is about system. So air system name, equipment type, air system type, number of zone, whatever it is. Okay, ventilation is direct ventilation, and here is a dedicated outdoor air system is an hided because we are not dealing about package unit. Okay, third one is zone component. So in the zone component, there is a space. So in the zone one is the corridor, and which is ground floor. Okay, and here is this table is about thermostat reading. Okay, set point, And the next is coil cooling coil data. So cooling coil data in this, you can see here the design supply temperature which is 12 degree, coil bypass factor 0.12, and cooling source is air cooled dx. Schedule is from January to December. Okay, and next is here you can see the sizing data. In the sizing data, there will be safety factor, sensible and latent, what we entered. Okay, so this is the input report. How to generate the output report? I will show you. Just select this, and you can generate. You can just right click, and you can see here the view design print view design result. You can view from here also. Okay, so just click there, and you can check this all system sizing summary, zone sizing summary, ventilation sizing summary. These three should be checked, and here whatever result, whatever report you want, you just select this. Okay, just check here. So I want all these reports. Let me select all this first. Okay, and then click on preview. So your software will generate the output report. So you can see here, this is your output report. So in the output report, you can see here the first one is air system information, then sizing calculation information from for the month of January to December, and sizing data is calculated. Number of zone is 1, floor area is given here 148 square meter, and location, then zone sizing, space sizing, all data is given here. In the second page, you can see this is the zone sizing summary. So this is the zone sizing summary. Okay. So in this again here, you can found here first one is terminal unit sizing data, cooling. About cooling here, terminal unit sizing data. So this zone name is corridor, and total coil load is 9.6 kilowatt. Okay, and sensible is 9.2 kilowatt. Cooling entering dry valve and wet valve is nothing but the entering air temperature. Okay, the return air temperature, and this is the leaving air temperature, which is leaving the coil after touching the coil. Once this is on coil, and this is the off coil, we can say. Okay, so on coil temperature is the room temperature, nothing but the room temperature, the temperature of the air which is coming from the room. So 25 degree, and dry wet bulb temperature is 16.6. Okay, living temperature is dry valve and wet valve. So the air which is leaving the coil, at that time the temperature is 12.5, and dry valve and wet valve is 11.5. Okay, and the time of peak load is July 1500 is nothing but 3 o'clock. Okay, and the zone liter per second per square meter is here. This is the terminal unit sizing data, cooling, and this is for the heating. So we are not dealing about heating, that's why this is 0. Okay, zone peak sensible load. In the peak sensible load, this July 15 at the time of 3 p.m. and the peak load, the zone cooling sensible is 8.8 kilowatt. Peak load is nothing but this is the sensible load. That time the heat is more. Okay, so 8.1 kilowatt is required. Okay, and the space load. So space load is nothing but here is the cooling sensible, and space load corridor, and sensible is 8.1. And peak time is July 15. Airflow. So airflow is given here in liter per second, which is 607 liter per second. Okay, next is your ventilation sizing report. So you can see here the summary of ventilation sizing method is sum of space outdoor airflow and space ventilation analysis, which is zone corridor. So this ventilation is for the corridor. And here is two methods. The total floor area is 148 square meter, and this area is multiplied by area liter per second per square meter is required. So this is the required outdoor air is 0.3 liters per second per square meter. So this this value is multiplied with this floor area plus number of people. So how many occupant is there? Zero occupant. So number of people into liter per second per person. So here is the required outdoor air. Liters per second per person is zero. So this is your outdoor air requirement 44.4. Okay. If you multiply this total floor area into 0.3, you will get this value. Let me show you how it comes. Okay. So 148 square meter into 0.3. Okay. So I am getting here 44.4, which is same here. This is outdoor air liter per second. If there is people in this corridor, so people is multiplied with liter per second per person. So if you add these two value, you will get this value. Okay. And this is your zone load. Okay. The latent and sensible heat, which is transmission and radiation load. Okay. And next is your zone design load summary. Okay, and this is your space air system design load summary. This is zone load. In the zone load, whatever latent radiation and load is there, and this is the space design load summary data, which is transmission and radiation load. And next is your hourly analysis, hourly air system design day load for the corridor. So each hours how much load in the corridor it is showing in this report, which is here you can see here. The zone corridor is designed for the month of July. So this is July is your peak load, peak month. Okay. So in this you can see here the total maximum temperature in the July is 41.7. Okay. 41.7 and RH is 44. So that time flow is required this much and total load sensible zone load is this much of watt. Okay. 8050 watts, which is 8.5 kilowatt. Okay. This is your hourly analysis data. Next is your system psychometric for corridor, which is for the July design for the July for the month of July 15. So in this you can see here the system data. So system data is nothing but here is your component. So in the component the ventilation here, ventilation return mixing, ventilation fan, zone here, plenum, return plenum, whatever it is. So it's showing here. Okay. And this is your zone data, and the next is your for the winter. Okay. So this is how it looks like the output report, and this is how to read and how to generate the output report. So I hope you guys learned something from this video. If you learned something from this video, so please do subscribe. If you are new on my channel, please do subscribe my channel and hit the bell icon as well, so that whenever I upload the video, any video, you will get directly notification of my video. So let me meet in this next tutorial. So thank you for watching my video. Thank you. Bye bye.